Hi, and welcome to the fourth video in a series of videos on partial derivatives and higher order derivatives. This is actually the last video for the partial derivatives part. Um, and the next video will focus on higher order derivatives. So gusto ko lang i-wrap up yung mga natitirang concepts about partial derivatives. So first, I want to give an equivalent definition of the partial derivatives of f of x, y. And also, hindi lang naman kasi function of two variables ang inaaral natin. So we also have functions of more than two variables. So I also want to discuss very quickly the notion of partial derivatives for these functions. All right. So as a remark, yung partial derivatives natin of f evaluated at AB, these are also given by the following limit. So for example, the partial derivative of f with respect to x, if you evaluate it at AB, this is equal to the limit of this expression. I will discuss later kung bakit equivalent yan dun sa nakita na natin before. And then we also have something similar. Okay. So i-focus lang natin attention natin dun sa first partial derivative, so fx. So mapapansin nyo, yung input natin, yung original input is AB. Okay, so nandito yon. So this is the original corresponding output kapag ito yung input natin. Tapos ito yung new set of input. So ito yung mga new set of outputs. So yung ito yun na. So if this is the old input, ito yung old output. And if this is the new input, ito yung new output. So ganun din, yung numerator dito, it encapsulates the difference in the output. So ito yung change in output natin. Okay? And dito, ang nagbabago lang sa input natin yung x. No? So from A, na iniiba natin siya to some other number. Let's call it x. Okay? So ito yung change in the input. So ganun din naman yan. This is the change in output over the change in the input x. Tapos, ang gusto natin i-limit, gusto natin yung change in the input x, gawin nating papuntang 0 na. So yung meaning, yung x gusto natin palapitin sa a para wala na tayong change in the input. So ganun lang din yun. This definition is equivalent to the one that we've already discussed. Okay. But bakit pa natin kailangan to? Well, kasi sa isang example sa discussion video, gagamitin ito. Okay. So this sometimes is very useful in computing the partial derivatives. Pero baka sabihin niya, marunong na po kami kumuha ng partial derivatives, di ba? Gawin mo lang, fix, imagine y sa constant, tapos differentiate with respect to x. Pero hindi nyo pa rin pwedeng kalimutan yung limit definition as you will see in this particular example. So please watch that video, okay? Para malaman nyo na hindi enough na marunong kayong gumamit ng techniques of differentiations. Sometimes you really need the limit definition. Okay? Tapos gaya ng sinabi ko, if you have a function of more than two variables, meron pa rin tayong concept ng partial derivatives. Yun nga lang kasi we have several inputs. So for each input, meron tayong isang partial derivative. Halimbawa dun sa f of xy, so meron tayong isang partial derivative for x, meron tayong isang partial derivative for y. So ganun din, if you have a function of x1 up to xn, meron tayo isang partial derivative for x1, isang partial derivative for x2, and so on, tapos isang partial derivative for xn. So for a total of n partial derivatives. Okay. The formal definition is given by the following. The partial derivative of f with respect to x sub I. So ganun din, yung denominator that will always be the change in the input, x sub I. Okay. So ano yung pagbabago sa x sub I? Tapos yung numerator here, ito yung corresponding change in the output kapag binago mo yung ith variable. So ito yung change in the ith component. And of course, everything provided the limit exists. Again, tedious kumuha ng partial derivative using the limit definition. So in most cases, you can just obtain the partial derivative by differentiating. So gamitin nyo lang yung natutunan nyo from Math 21. Just differentiate with respect to the variable x sub I, and then just treat every other variable as a constant. So isipin nyo lahat na makikita nyong letter doon na hindi x sub I, constant lang, and then just differentiate normally. Okay. Also several notations, ganun din. So for the partial derivative with respect to x sub I, you can use d sub x sub I. Yun yung parang d sub x and d sub y natin from before. And then we still have the partial notation. So partial u over partial x sub I, meaning the partial derivative of u with respect to x sub I. Okay, and u is equal to f. Okay. So pwede ring partial f with respect to x sub I. Okay. So just one example. Halimbawa, we have f of x, y, z. This is equal to xz over y squared plus sine of 2x plus 3y plus 4z plus e raised to x squared z. So tatlo na yung input variable natin. So meaning meron na yung tayong tatlong partial derivatives, fx, fy, and fz. Okay. So kung gusto natin kuhanin yung partial derivative with respect to x, ang gagawin natin, iisipin natin yung z tsaka y is a constant. So halimbawa, sa example na to, yung first term, this z over y squared is a constant. So constant times x lang yan. So ang derivative ng constant times x ay yung constant. So pag differentiate niya, that's going to be z over y squared, yung constant. Tapos yung next term natin, it's a sine of a function. So you just use the chain rule. So makukuha nyo cosine of the inside function. Ito yan. Times the derivative of the inside function with respect to x. Okay, so yung 3y and 4z, those are constants. So pag dinifferentiate mo, mamamatay lang sila. So magiging 0. So ang i-differentiate mo lang yung 2x. And the derivative of 2x is of course 2. Okay. And same with the last term. Okay, e raised to a function, pag dinifferentiate mo yung e to the function, makukuha mo yung e to the function pa rin, times derivative of x squared z. Again, z here is a constant. So you get z times derivative of x squared, which is 2x. So ito yan. So ganun din for f sub y, here the constants are x and z. Okay, so ang derivative ng first term ay xz times negative 2 over y cubed. Yung negative 2 over y cubed, that's the derivative of 1 over y squared. Okay, and same here, ang derivative na second term ay cosine times 3. Kasi ang makukuha nyo from differentiating the inside ay 3. Ito naman yung mga mamamatay, yung mga x and mga z. Kasi constants na sila. Tapos yung third term, wala na, no? Kasi wala namang y yan eh. So that's just a constant. So the derivative of is 0. So ito na yun. Okay. And finally, for fz, I'll just leave this to you. So paki-verify that the derivative of the first term is x over y squared. The derivative of the second term is 4 times cosine of 2x plus 3y plus 4z. And the derivative of the third term is, I think it should be e to the x squared z times x squared. Yeah, okay. So, hindi natin binigyan ng geometric interpretation yung partial derivatives of functions of more than two variables kasi unang-una yung halimbawa pag meron kang u equals f of x, y, z, hindi na natin siya basta-basta mag-graph na. So pwede nyo na lang siyang isipin as a rate of change. Okay? Wala na nung slope interpretation. Okay? For this video, ang ginawa lang natin is to give an equivalent definition of the partial derivatives. Okay? and to discuss partial derivatives of functions of more than two variables.